All right, ladies and gentlemen, welcome to your first flipped classroom video. I'd like to take this opportunity to tell you how excited I am about getting started with this, and also to remind you that you can pause and rewind and fast forward and do whatever you need to do to make yourself comfortable. Work at your own pace. And I'd also remind you that you're going to need to have paper and pencil, maybe a straight edge. I'd like you to go ahead and have your book out so you can follow along in your book with what we're doing. The object here, or the objective, is that I want this to be as much like you being in class as possible. So I'll go ahead and give you an opportunity to pause the video at this point to go ahead and open your book to page 188, section 3.3. Get out paper, pencil, and wouldn't be a bad idea to maybe have some graph paper for this particular video. So if you would, go ahead and, if you don't have those things, pause the video and take a minute and gather those things so we can get started. All right, now that we have everything that we need, let's go ahead and get started with our lecture for section 3.3. I'd like to start with just a little review of what slope is. In a coordinate plane, the slope of a line is the ratio of change from the x-axis to the y-axis between any 2 points on a line. So really what we're doing here is we're measuring the steepness of a line, and we're using a fraction or a ratio to indicate how steep or how not steep a line is. And we have two ways that we can go about completing this task. We can either use the coordinate plane itself and count from one point to the other. How many units am I going up or down? And we refer to this as our rise. And then count over however many units I need to get to my other point, and we refer to this as run. Okay, so you see here that we can refer to this as rise over run. And if you're counting down, you have a negative value, and if you're counting left, you have a negative value. And the same can be counted in the other direction. Okay, so I can go up, which would be a positive value, and right, which would be a positive value. So when you're counting, just make sure that you're paying attention what direction you're headed. If you're going down or to the left, that's negative. If you're going up or to the right, then that's positive. Okay? And we also have a slope formula that allows us to find the slope if we have the coordinates, okay? Which, if we're in the coordinate plane, we always can find the coordinates. Okay? So if my points are labeled as x1, y1, x2, y2, then the slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so let's get just a little review and make sure that everybody's on the same page with finding slope. Okay, the first way that we would do this is we could count our rise and our run. So I always like to start with the lowest point so that I'm always moving up with my rise. It just makes it easier for me. You can do it whichever way you'd like, but I'm going to start with J. So starting with J, I'm going to go up 1, 2, 3, 4, 5 units. Okay, so in this case, my rise would be a positive 5. And then I'm going to go from here to the right 1, 2, 3, 4 units. Okay, so my run, since I'm going to the right, would also be a positive 4. And this is counting your rise and your run. Okay, then we also have the option of using our slope formula, our y2 minus y1 divided by x2 minus x1. Okay, well, if I'm going to use this formula, then I have to have values to plug in here. So what's missing for me to be able to use this are what my coordinates are. So that's going to be first and foremost, if I want to use the slope formula, is defining where my coordinates are on the line. So starting at the origin, point J would be at -1, -2. point K would be at positive 1, 2, 3, positive 1, 2, 3. All right, now that I have some points, I can label them as x1, y1, x2, y2, and plug them in. And you can label whichever way you want to label. It's not going to matter because the steepness of your line is not going to change depending on which way you're finding the slope. So I'll label this as x1, y1, and I'll label this as x2, y2. And if you want, label yours the opposite way just so you can see that it doesn't matter which way you label. All right, now plugging into my slope formula, I have y2, which has a value of 3 here, minus y1, which has a value of negative 2. And be careful with your signs there. Okay, it's always going to be minus. So if you have a negative value, let's go ahead and use parentheses like I have here to plug that in. Then I have x2, which also has a value of 3, minus x1. Okay, so once we plug in, we simply subtract in the numerator and subtract in the denominator. 3 minus a negative 2 is a positive 5, and 3 minus a negative 1 is a positive 4. So either way you slice it, if you want to count the rise and run, or if you want to find the points, label them and plug them in, your slope of the line is 5/4. Okay, so now that we are reviewed on slope, let's move on to what the lesson is really about, which is the slopes of parallel and perpendicular lines. And just a quick review here before we get into that of what a positive slope, a negative slope, a zero slope, and an undefined slope look like. And the positive and negative are usually fairly easy to remember. The zero and the undefined is where people usually have the most problems. Okay, the reason this is zero, if you'll notice, we're moving only along the x-axis, which means my y value is not going to change. So when I plug into my slope formula, I'm going to have a 0 in the numerator because I'm going to be subtracting the same number from itself. Well, 0 divided by anything is always going to be equal to 0. Okay, so all horizontal lines have a slope of 0. Vertical lines have an undefined slope for a very similar reason. Here we're only moving along the y-axis, meaning that when I plug into the slope formula, the denominator will have a 0 because I'm subtracting the same x value from itself. And anytime you have a 0 in the denominator, it doesn't matter what value is in the numerator, you have an undefined value. All right? So now, moving on to parallel and perpendicular lines. If you want, go ahead and pause the video here and take a minute to copy down these two postulates, 3.2 and 3.3, and then we'll talk about them together. All right, now that you have those copied down, let's take a look at them together. Okay, postulate 3.2 says that two non-vertical lines have the same slope if and only if they are parallel. This also goes in the other direction. Two lines are parallel if and only if they have the same slope. Okay, same deal for perpendicular lines. I have an if and only if statement that will go in both directions. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Going in the other direction, if the product of the slopes is -1, then the lines are perpendicular. And we will use both directions of these statements at one time or another. Okay, so talking about parallel lines and looking at our example. It says parallel lines L and M have the same slope of 4, and it should make fairly good common sense to you that if two lines have the same slope value and the same steepness, that they will be parallel, which means they'll never touch because they have the same steepness. Okay? And then looking at our example here, it shows us that line M is perpendicular to line P because when I multiply their slopes, I get a product of -1. Okay, so we're going to use this statement and this statement in both directions throughout our use of parallel and perpendicular lines. So let's look at an example of how this might be used. And let me take a second here just to make sure that my technology is not failing me. Okay, I just wanted to make sure that I was still recording. All right, back to my examples. Okay, it says determine whether line AB and line CD are parallel, perpendicular, or neither. So the way that I'm going to go about this is I'm going to graph these lines, find their slopes, and then compare them to one another. Okay, so I have 4 points that I need to plot, and then draw my lines, find the slopes, and compare them. Okay, so you probably would want to do this on some graph paper. Okay, so for example 3A, let's go ahead and first plot our points. Point A is located at 1413, and looks like I'm not going to have quite enough room, so I'm just going to go as far as I can, and we're going to label it 1413. Point B is at negative 11, 0, which is going to be way over here. Label it as negative 11, 0. So let's go ahead and draw our line through these 2 points, and I'm going to do as best I can to make it go through the 2 points with them being that far apart. Kind of hard to get that to go through, but it looks like I did a decent job. All right, and point C is located at negative 3, positive 7. And point D is located at negative 4, negative 5. So there is line CD. Oh, and I forgot to label those. So let's go ahead and label that C, negative 3, positive 7, and D is at negative 4, negative 5. All right. Now, we are humans, which means when we graph things such as this, that we make slight errors. So I can say with a certain amount of confidence that these 2 lines are obviously not parallel because they intersect. However, I don't know for absolute certain that I didn't draw my lines in such a way that they were supposed to have been perpendicular, but they ended up not perpendicular because of something that I did incorrectly. So what I'm going to do is I'm going to find the slope of both lines. So find the slope of CD, and then I'm going to find the slope of line AB, and I'm going to compare them. Okay, I'm going to multiply them together and see if they have a value of negative 1. If they do, then they are perpendicular. If they don't, then they are not. So let's get a fresh sheet of paper, and let's find the slope first of line AB. And I'm going to use the slope formula here. Okay, so y2 minus y1 in this case could be 13 minus 0. x2 minus x1 would be 14 minus negative 11. Okay, this would give me a positive 13 over a positive 25. For line CD, plugging into the slope formula, we would have 7 minus negative 5 divided by negative 3 minus negative 4, giving me a positive 12 over a positive 1 for the slope of line CD. So obviously the slope